Tuning by layers. Reduce application demand to its logical minimum by tuning SQL and PL/SQL and optimizing physical design. Maximum, second point, maximize concurrency by minimizing contention for locks, latches, buffers, etc. Third, minimize amount of physical I/O by optimizing Oracle memory. Fourth, reduce I/O latency by providing adequate I/O bandwidth and evenly distributing the resulting load. Fourth, no. Hours of design effort at this stage saves weeks of tuning effects later. Database design, subtypes and supertypes, data types, especially LOB strategy, denormalization, fourth, partitioning, fifth, null value, sixth, data warehousing consideration, star snowflakes, materialize views. Application design and implementation follow best practices, bind variables and cursor handling. Make sure bind variables are used. Consider cursor sharing and session cache cursor to mitigate poor cursor handling. Second, locking model. Use optimistic locking where appropriate. Minimize log duration always. Third, array processing. Fourth, consider stored procedures where network interactions are critical. Fifth, caching. The best tuned SQL is the one if you don't sell. Optimizing network traffic. PL/SQL routine most massively outperform other languages when network round trips are significant. 2. Index wisely. Indexes exist primarily to improve performance. Beware of index cost as well as benefit. Creating appropriate concatenated index is the most important factor for most applications. Consider non-standard indexing techniques and indexing alternatives. Bitmap indexes, hash cluster, functional indexes, partition elimination. Bitmap indexes are okay for high cardinality columns. Key tools free with version of Oracle, DBMSX plan, cache SQL statistics, weight interface and time model, SQL trace and tkprof, Oracle tuning and diagnostic packs, commercial tools like Spotlight. Okay, explain plan for select department name for HR. Right. Cache SQL information. SQL information can be found in v$SQL, v$SQL underscore plan, v$SQL underscore plan statistics. Okay, okay. Right. Execution plan shows detailed steps necessary to execute a SQL statement. The steps are expressed as a set of operators that consumes and produces rows. Second, order of operators and their implementation is decided by the optimizer using the optimization techniques. Third, understanding execution plan. They are based upon cardinality, access path, join type, and join order. Two ways to look at the execution plan. Explain plan or v$_SQL underscore plan. Good plan for the optimizer. Optimizer has two different goals: serial execution and parallel execution. Serial execution is all about cost, cheaper the better. Parallel execution is all about performance, faster the better. Third, this raises two important questions: what is cost, what is performance? Cost is a magical number the optimizer makes up. Resources required to execute a SQL statement. Result of complex calculation. Estimate of how long it will take to execute a statement. Cost represents units of work or resources used. Optimizing uses CPU and I/O as units of work. Cost is an estimate of the amount of CPU and the number of disk I/Os used to perform an operation. What is performance? Getting as many queries completed as possible. Getting fastest possible elapsed time using fewest resources. Third, getting the best concurrency rate. Fourth, performance is fastest possible response time for a query. Goal is to complete the query as quickly as possible. B. Optimizer does not focus on resources needed to execute the plan. Understanding execution plan. Cardinality. Estimate of number of rows that will be returned for by each operation. B. Cardinality of single column is equal to total number of rows by number of distinct values. C. Influences everything. Access method, join type, join order. D. In an execution plan, cardinality can be determined by rows columns. SQL Monitor is the easiest way to compare the estimated number of rows written for each operation in a parallel plan to actual rows returned. Access path. Full table scan reads all rows from a table and filters out those that do not meet the where clause predicate, used when no index, GOP, set, etc. B. Table access by row ID. Row ID specifies the data file and data block containing the row and the location of the row in that block used if row ID is applied by an index or in the where clause. Index unique scan. Only one row will be returned. Used when statement contains a unique or primary key constraint that guarantees that a single row is accessed. Index range scan. Okay, these are some of the phrases that are SQL things that you can see in the execution plan. Index range scan accesses adjacent index entries, row ID values with equality of for equality or non-unique indexes. Index skip scan skips the leading edge of the index and uses the rest advantages if there are few distinct values in the leading column and many distinct values in the non-leading column. Okay, a full index scan processes all leaf blocks of an index but only enough branch blocks to find first leaf block, used when all necessary columns are in index and order by clause match index structure or if sort merge join is done. Fast full index scans all blocks in the index used to replace FTS when all necessary columns are in index. Uses multi-block IO and using parallel. Okay, index joins hash join of several indexes that together contain all the tables of columns that are referenced in a query. Won't eliminate a sort operation. Bitmap index uses a bitmap for key values and mapping function that converts each bit position to a row ID, can sufficiently merge indexes that correspond to several conditions in a where clause. Issue cause use table scan index of an index. DOP on table but not index. Value of MBRC picks wrong index, stale or missing statistics. Cost of full index access is cheaper than index lookup, followed by table access picks index that matches most number of columns. Join type nested loops. For every row in the outer table, Oracle access all the rows in the inner table, usually when joining small subsets of data. There is an efficient way to access the second table. Hash join. The smaller of the two tables scanned and the resulting rows are used to build a hash table for the join key in the memory. The larger table is then scanned. Join column if the resulting rows are hashed and the values used to proving the hash table to find the matching rows, useful for larger tables and if an equality predicate is mentioned. Sort merge join consists of two steps. Both the inputs are sorted on the join key. The sorted lists are merged together, useful when the join condition between the table is inequality condition or one of the table is already ordered. Cartesian join joins every row from one data source with every from the other data source, creating Cartesian product of two sets. Only good if tables are small. Only choice is if there is no condition specified in a query. Outer join returns all rows that satisfy a join condition. Also returns all of the rows from the table without star for which no rows from the outer table satisfy the join condition. Join orders. The order in which the tables are joined in multi-table statement. Ideally start with tables that will eliminate the most rows, strongly affected by the access paths available. Joins guaranteed to produce utmost one row always goes first. When outer joins are used, the table with outer join operator must come after the outer table in the predicate. If view merging is not possible, all tables in the view will be joined before joining to the tables outside the view. Explain plan. Explain plan statement displays execution plans for select, update, insert and delete statement. The statement execution plan is a sequence of operations that Oracle performs to run the statement. The row source tree is a core of execution plan. It joins ordering of the table, access method for each table, join method for table, date operations for like filter, sort or aggregation. The plan table also contains information optimizing such as the cost and cardinality for each operation, partitioning such as the set of access partitions, parallel execution such as distribution method of join inputs. Right. Full table scan. This type of scan reads all rows from the table and filters out those that do not meet the selection criteria. Reading a full table scan, all blocks in the table that are under the high watermark are scanned. The high watermark indicates that the amount of view space or space that had been formatted to receive data. Each row is examined to determine whether it satisfies the statement's where clause. Row ID of a row specifies the data files and data block containing the row and the location of the row in the block. Locating a row by specifying its row ID is the fastest way to retrieve a single row because the exact location of the row in the database is specified. To access a table by row ID, Oracle first obtains the row IDs of the selected rows either from the statement where clause or through an index scan or one or more of the table's indexes. Oracle then locates each selected row from the table based on its row ID. Index scan. In this method, a row is written by the traversing the index using the index column values specified by the statement. Index can retrieve data from an index based on the value of one or more columns in the index. To perform an index scan, Oracle searches the index for the index column values accessed by the statement. If the statement accesses only columns of an index, Oracle reads the index column values directly from the index rather than from the table. The index contains not only the index value but also the row ID of the rows the table having the value. Therefore, if the statement accesses other columns in addition to the index columns, Oracle can find the rows in the table by either using table access by row ID or the cluster scan. Accessing I/O for blocks, not rows, index unique scan, index range scan, index range scan, descending, index skip scan, full scan, fast full index scan, bitmap join. Okay. Optimizer parameter, optimizer mode, optimizer index cost adjacent, optimizer index caching, optimizer feature enable. Okay, those are some of the optimizer parameter. SQL and PR SQL tuning. Some SQLs get through the optimizer net and always well. Find the sequence using the tools outlined about. Tune by tweaking the optimizer, creating indexes, changing the plan. Things to tune: table access, joins and subqueries, sorts and aggregates, PL SQL, parallel SQL, DML. Optimizer joins: best join order. Eliminate rows as early as possible. Join type: nested loops. Optimize the join index. Sort merge. Avoid, especially if memory is scarce. Hash join. Avoid multipass execution. Types of logs. Contention logs, mostly application but occasionally system, SQ, HW, ST. Latches, mutexes, often side effects of excessive application demand. Lack of bind variables, but sometimes the final constraints on DB throughput. Buffers, buffer cache, redo buffer, etc. Hard blocks, buffer busy, slow, lazy writer process, DB writer, log writer, RV writer. Reduce the physical I/O by optimizing memory. Memory is used to cache data and to perform sorting and hashing. Memory and sorting. Nothing matters as much as PGA to sort operation. Automatic work area management restricts you to a subset of PGA. For big sorts, opt out of automatic work area management. Alter session, set work area size policy is equal to mandate. Right. Bad connection management, bad use of cursors and the shared, bad SQL, use of non-standard initialization parameter, getting database I/O wrong, reader log setup problems, long full table scans, high amount of the cursor sequence. Application lock waits caused by row level locking, comments, waits for redo log, write confirmation after comment, idle signify the session is inactive, network, wait for data to be sent over the network, user I/O wait for blocks to be read of a time. Those are some of the documented notes. Thank you for listening.